we're just not going to get to it. So there's all sorts of stuff about chemistry that I've chosen not to emphasize, okay? Just because I kind of want to, you know, get to the meat and potatoes of things, all right? So, so here we go. We're focusing on the elements. So actually, when we're focusing on the elements, we're talking about an atom of one type, okay? Just like all copper atoms or all aluminum atoms, okay, that's an element. We'll be talking a little more about that. But we said, actually, I'm going to pull this back in again, how is matter classified? And hopefully we'll be kind of hitting this a little bit more as we go. But we said right off the bat that all matter is made up of atoms, okay? So atoms make up matter, okay? All matter is made up of atoms. Now, if those atoms are the same, okay, if all those cute little atoms are like I said, copper atoms or all oxygen atoms, we have what we call an element, okay? If those atoms have bonded together with another element, okay, if we have two or more elements that are stuck together with a chemical bond, that's actually called a compound. So both elements and compounds, they are considered what we call pure substances, okay? So the deal is you know that you have pure, the same repeating unit or the same specific atom. So later on, we'll probably spend a little bit of time talking about mixtures. If something isn't a pure substance, it's a mixture. And if it's a mixture, it can either be the same throughout, a homogeneous mixture, or it can be kind of chunky, a heterogeneous mixture. So, talking about elements. So definitely on your next unit exam, I will give you one of these. Periodic table of elements. This one looks so dry, but I like to hand this out so you know what you're going to get. Now on your next unit exam, you can also bring did I go 4x6? Note card with you. You can do that too. But I'll give you one of these. Notice that, weird one. Notice that these do not have the names on it, okay? So here in a minute, I'm going to go ahead and tell you which elements you need to know the name of. So for instance, if I give you the letter C, what element is that? Carbon. Carbon. You need to know the name carbon goes with the letter C, exactly. How about the letter N? Nitrogen. Nitrogen, exactly. So I'll kind of give you a list of those. So I'm giving this to you in case you want to kind of mark it up. Sometimes students like to mark up a periodic table, and there you go. There's one to mark up. Okay. So each box represents a different element. There actually, right now, there are 118 elements that are confirmed for sure. The problem is, and we'll kind of talk about this, but do you see where I brought this in, this screenshot. I like this periodic table because do you see these white ones down here? Rutherfordium, Halifax, Seaburn, those white ones? Those white ones are like, they're legitimate elements, but they are not stable. They basically, sorry, they are not stable. They are stable. They're legitimate elements, they are stable, but they don't naturally occur, okay? They're unstable to the point, however long our solar system has been in existence, about 4.6 billion years, they have broken apart. So maybe, like, I don't know, maybe 2 billion years ago, we had those elements, but they have broken down, okay? It's called radioactive decay. So 98 naturally occurring elements. I tell students, if you want to know where the unnatural elements are, if you find uranium, okay, what's the symbol for uranium? It's U. If you find uranium, by golly, you know where the elements that are no longer here are, okay? So after uranium, we have things that are not available to us, naturally occurring. Most of the elements are actually solids. There are just a few that are gases and only 2 that are liquids. So the 2 that are liquids are shown on here. I'll go ahead and circle them. I want to start getting a sense for that. The 2 that are liquids, mercury, the symbol for mercury is Hg, and the symbol for bromine is Br. Those are liquids. And the gases actually here are in red. So we definitely have some gases. So all of these are gases. Okay, kind of this L-shaped thing here is gas. Okay, and of course hydrogen is a gas. So we definitely have some gases. All of the black ones, right, are solids. And actually the ones that don't exist naturally are also solids. Now, I will caution you because can you imagine if you're on a planet that's like a lot hotter than the Earth? Okay, actually some of these others might be liquids or gases too. Okay, so one of the things we need to do today is to look at the elements and look at how elements are usually presented. Elements are usually presented kind of nice and orderly. We'll talk about that order on the periodic table. And we're going to have to be able to kind of chunk up the periodic table. So one of the first things right off the bat is, do you see the pink and the blue over here? Okay, and actually the periodic table I gave you has, I call it the JAG. And this, I don't know if this red is showing up. Okay, there is our JAG. Kind of looks like stair steps. That is the JAG. The thing about the JAG is it actually on the periodic table is important for separating metals on the left. I get my left and rights mixed up. So all of these over here on the left are metals. Okay, and on the right are nonmetals. So what do you think right off the bat? With regard to the number of elements of each type, would you say there's more metals or fewer metals? There's more metals, yeah, a lot more metals than there are nonmetals. But if we focus on that cute, I kind of call this nonmetals up here, this purple nonmetals, I kind of call that like it looks like a triangle to me. This little small group of elements that are nonmetals, those are very important. Nonmetals. If you're familiar with there's different kind of branches of chemistry. There's a branch of chemistry called organic chemistry or life chemistry. And actually, these elements are just definitely players. These nonmetals, definitely organic chemistry. It's just crazy. But the metals are very important. So in part one, this is part two in chemistry. In part one in chemistry, we talked about the pieces of an atom, and the nucleus of an atom is home to the protons, right, and the neutrons. Okay, protons and neutrons. So protons, do you remember, is actually what says what type of element it is. Okay, protons is what we call the atomic number. So I'm going to go ahead and be referring to that. Actually, I checked in my notes. I already used that term before, atomic number. Okay, atomic number. The atomic number in your textbook, I'll just go ahead and throw it here, is actually the symbol Z. My Z's, in order to differentiate them from 2's, I usually kind of put a little bar kind of in the long part. So if you want to put Z next to atomic number, it'd be a good idea. Z is atomic number. It's the number of protons in an atom of that sort of element. And I told you it's the whole number, so let's go ahead and find some whole numbers, all right? So let's just go ahead and go hydrogen, 1, helium, 2, lithium, 3, beryllium, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you get the idea. Basically, we go across, and then we go down, and we go across again. Okay? Increasing atomic number. What's atomic number? The number of protons in the nucleus of an atom of that type of element. Okay? Protons. They totally rock. Okay? So in astronomy, when we study stars, I'll go ahead and circle atomic number 26 there. When we study stars, this particular element with 26 protons is kind of a breaking point where a star kind of needs to stop doing what it's doing, basically. It kind of hits a brick wall with when it involves iron. All right, so there we go. Periodic table. Everybody loves the periodic table. Actually, Dmitri Mendeleev, way back when, it's thought that in a dream, the dude actually saw, that's kind of creepy, and I think of it sometimes, he saw these boxes of elements kind of floating around in a dream, and he's like, hey, I kind of recognize a pattern there. Okay, so Dmitry Mendeleev, let's give him credit. I'm going to probably really, Dmitry Mendeleev. Way back when. I kind of tease because I kind of say, I bet his wife had something to do with it somewhere. Because behind every great man is a great woman. Okay, I guess behind every great woman is a great man too. So anyway, these elements are always going to be kind of in this order for a reason. Okay, they are what we call periodic. And my thing about the elements and the periodic table is if you think they're very similar to me to when you look at a calendar. I'll kind of show you what I mean. So, for instance, if you look at a calendar, it's always organized, you know, sometimes, let's go ahead and say it starts with Sunday. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Okay? So, to me, if you're like me, I do very certain things on Sunday, right? I do Mondays, not my favorite, right? Tuesdays, a little better. Wednesdays, guess what day it is, right? Okay, Thursdays, we have lab. Okay, Fridays, we're all happy, smiles all the way around. Saturdays, we're very happy, we get things done. And then Sundays, we gear up for our week. Okay, so each of these days of the week have a very similar feel to them. Okay, so you do 1 week, and then you go back and you do another week. Not exactly like Groundhog Day, but, and then you go back and you do another week. Okay, so as we look at a calendar, wouldn't you say that your Sundays are very similar? Plus or minus, okay? That your Mondays are very similar, okay? That your Tuesdays are all very similar, okay? That means that basically what we do in our lives is what we call periodic. It comes back around. It just comes back around, okay? I know there's some variation in our lives, hopefully. But actually, that's what the elements do. So that's to say that just like if you look at a calendar, the M for Monday is most important to describe those elements. So also as we consider elements with the same properties, we kind of look like this, just like a calendar. Okay, so I've kind of picked on, looks like I picked on the second column. Okay, the second column, and actually here in a minute I have a name for that. The column is called a group. Okay, so the second group starts with beryllium, magnesium, calcium, strontium, barium, and radium. Okay, you kind of know what they're going to do chemically. They have similar chemical properties. I will go ahead and say I can see from here radium is like, oh my gosh, the red number is 88. It's got 88 protons. Really? Magnesium has 12. So here we have, if you think this is heavier, it is. Radium is heavier, magnesium is lighter. But they have similar chemical properties. Okay? So it's called the law of periodicity. All right. So vertical columns are called groups. So all this animation does is go like this. Okay, this is kind of like days of the week. So these are all similar. Where you see kind of the yellow group, they all have similar properties. Okay, because it came back around. And we're going to look in a minute just briefly why do they have similar properties. I have in a minute to certain groups that you need to commit to memory. Okay. But before I move on and give you some names of a group, like, Mondays are this one, Tuesdays are this one. Before I do that, another way, or just in general, here, what I'm circling are the group names, okay? So, for instance, beryllium, that one, the second group, we could call that group 2, or we could call that group 2A. They're kind of two different naming systems, unfortunately, okay? We could call this one here group 3 or 3B. Group. Now, one of the things, if you're like me, and I still scratch my head, and I've been teaching, general chemistry for a while, okay, but check this out. If we go clear over here to group 15 and or group 5A, you're going to see that I prefer 5A over 15, okay? So, but group 5A, check out. It basically goes through the jag because we have nitrogen and phosphorus, which is on that side of the jag, right? So those are non-metals. And then we have arsenic, which kind of goes a little bit both. And then SB is antimony, and then we have bismuth. Okay, so basically the group is, okay, but similar properties. This one actually emphasizes something called periods. So period would be like your week, like week 1, week 2, okay, period 1, period 2, okay? There are not necessarily similar chemical properties of the elements in the same period. In the black and white table that I gave you, periodic table, over here on the far left, you see some numbers, these cute little numbers here. Those are the period numbers, okay? Those are the period numbers. Oh, she's already like making her periodic table so pretty. Good for you, Kennedy. Okay. Yep, so those are little period numbers. And so period is like crossed. All right, that works. Okay, so groups. Notice there's no jag on this periodic table. It's just the way the figure is trying to emphasize something else, okay? But groups. So I said know these group names. And as I was getting ready for today's lecture, I'm like, wait a minute, where are the group names? I'm like, oh, wait, they're on the figure, okay? So down here, you need to know that 1A, let's see, 1A, group 1A are the alkali metals. Okay, group 2A are the alkaline earth metals. See how that goes? Okay, there's only 4 groups I need you to know the real name for. So just to make sure we're all on the same page here, if I'm going to circle, for instance, pick on alkali metals, I'm going to go like this. Okay, that are the alkali metals. Notice this periodic table doesn't have the elemental name or anything in it. I kind of almost think that, well, 2 ways. You can think they got lazy, so they didn't want to put, for instance, zoom in here. This is hydrogen. You know, I can compare periodic tables. That's hydrogen. This is lithium. This is beryllium. Okay, sodium and magnesium, Na and Mg are down below it. It's just a way to kind of see the periodic table without the elements, but they're there. I didn't think about it till just now, but sometimes you're probably like, wait, where are the elements? Well, each box is an element. Okay, and then the other 2 groups you need to know the name of, probably may already sound familiar. You need to know the halogens are 7A, and the noble gases are 8A. Under noble gases, which is a great name for these guys over here, I'll go ahead and give you a few other names for the noble gases. Okay. Under noble gases, sometimes they're called the inert gases. And then sometimes they are called the rare gases. Because guess what? They are inert and rare. If you think of if you get a medicine and your medicine says the active ingredient and the inert ingredient, that inert ingredient is kind of what they call, I guess, a binder in your medicine. Basically, it's just kind of filler. So an element that is inert, like all of those are, all those noble gases are, those rare gases are, it doesn't do anything. It basically is filler. Okay, it doesn't want to react. That's my point. It does not want to react. So these 3 names are all the same. Before I go on, click one more. So notice another way to chunk up the periodic table are something called the representative elements. So the representative elements are there in green. You're like, dude, really? Yes, really. Okay, so everything in green, okay, those are, and if you're colorblind, don't become a chemist. No. I'm sure there's ways around it, but if you're colorblind or can't smell, that could be problematic. Or can't see. I know, but I just think that would be hard. So they're green. So what does that mean? Representative elements, there are basically 2 groups over here. 1, 2, and there are 6 groups over here. 1, 2, 3, 4, 5, 6. 6 groups called the representative elements. I'll go ahead and tell on myself, so you kind of date myself. But I learned the main group elements as Group A. Group A elements. And can you see why that is? Because if you look at the group name, we have 1A, 2A, then we skip something, and then we have 3A, 4A, 5A, 6A, 7A, and 8A. Okay, sometimes I call them Group A elements. Periodic table, it is your friend. Actually, the thing that we skip are the transition elements, aren't they? Let's see, transition elements. Kind of surprised I didn't. I'm going to go ahead and circle that on here in case I didn't mention it later on in my slide. Okay, the blue are the transition elements. And guess what? I learned these as Group B. And I'm going to address these here in a minute, but I'm going to go ahead down here. These two miscellaneous periods, they look like periods, but they're kind of not. These two miscellaneous rows down here, I'm going to go ahead, and they are also part of Group B. They are also transition elements. Transition. They are called intertransition. Okay, so that's kind of that's another way to chunk up the periodic table. So here, actually, you guys don't have this slide, but I printed it out. This is where sometimes students take their periodic table and highlight it to make sure that they can identify, like carbon is C, hydrogen is H. Some of these are harder. Like, what's the symbol for silver? A. Oops, I got somebody else's stuff. What's that? On here. Sometimes these are good, make good flashcards. Not AR. It's not AU, that's gold. AG, yeah, I get those mixed up.
Just start going through all of them. Just go.
It is AG, silver. So, but as much as you kind of, and I probably will on this test, like I've done before, pick some of these elements and just have you give me this, I give you the symbol, you give me the name, and I give you the name, you give me the symbol. Okay. And now the way this works, that sheet that works that I just gave you, notice these are listed by atomic number. So what element is atomic number 36? And actually, remember you're going to have this. So what element is atomic number 36? It is Br. Wait, no, it's not Br. Kr. Krypton. Yeah. So that's one that you're going to want to know. Kr is krypton. Okay. So don't spend all your time studying for these, but I will go ahead and put a little section on your next your exam for chemistry and ask you, Okay. All right. So what the heck, right? So why does it loop back around so that when we end up with our periodic table, these elements have similar properties? And it has to do with electrons. So remember, starting with the Bohr model and then the Schrodinger model, we say basically electrons have a certain energy associated with them. Okay. I don't know how much in depth I'm going to go into this necessarily, but just in general, these are diagrams down here showing you what the electrons are doing. So the way you read these diagrams is the blue thing is the nucleus. So nucleus, gotta love it. And in the nucleus, we said it has the protons and the neutrons. So here we have hydrogen with one proton. So it's +1 in the nucleus. Okay, let's pick on something else. Let's go over here to oxygen. Find oxygen over here. Okay, and oxygen is 8, atomic number 8. So it has 8 protons, and that's actually what's being shown here. Okay, 8 protons. Now, we said, and we'll talk a little bit about when they're not neutral, but we said if an atom is neutral, then the number of electrons are the same as the number of protons. So if we continue to pick on oxygen, actually if it has 8 protons, it needs to have 8 electrons. So that 2 and that 6, they add up to 8. The 2 and the 6 actually are showing you kind of how those 8 electrons around that oxygen atom are hanging out. 2 of them are hanging out at this energy level, so these are different energy levels. I'll call this energy level 1 and energy level 2. 2 electrons around that oxygen atom are hanging out at the energy level 1. 6 electrons are hanging out at energy level 2. Okay?
Does the highest number it goes up to on the second and third one, is that the highest number is 8 on all of them, or does it go higher than 8 on the third one?
On the principal energy level, I think it will go higher than 8.
Okay.
Yeah. In fact, the reason I kind of stopped, or your author stopped the figure here, by the way, these 1, 2, and 3, those are the periods. You know, we talked about periods. If you go back and find hydrogen, hydrogen is period 1. Okay, these are the periods. You know, they're that. Okay. So what I really want you to know is kind of a little bit that electrons are organized, and you see them organized, but they do go higher than 8. But what's important here are what we call the valence electrons. So before I go on, I'm going to say valence electrons. Okay, the term is on your sheet, I think, valence electrons. And I will point to where the valence electrons are. Valence electrons are the outer, I'll just go ahead and put E there. They're outer electrons. So let's look at outer electrons. So if we look at oxygen, okay, the outer electrons are 6. Okay? Outer electrons are 6. Let's look at sulfur right underneath oxygen. What are the outer electrons? Valence electrons, also 6. Okay, let's go over a group to 5A. Let's look at nitrogen, the outer electrons 5. Phosphorus, outer electrons 5. Okay, carbon, outer electrons 4. Silicon, outer electrons 4. So they have the same outer electrons. They have the same valence electrons. Okay, and that's where their similarities begin. That's the essence of their similarities. We're going to see it's all about electrons as to whether these things want to combine with another atom or not. Okay, it's all about electrons, whether these things want to become an ion. Okay, so specifically valence electrons. Okay, so those outer electrons are called valence electrons. And the inner electrons are called inner electrons. So you have inner electrons plus valence electrons. So one of the things that is very handy is this last thing. I think it's the last thing. So if we go back to oxygen and pick on oxygen and what's underneath sulfur, okay, we said that basically of these 8 electrons around an oxygen atom, 6 of them are special valence electrons. And notice it's in 6A. Okay, 6. Let's go over to the right this time. Group 7A. Okay, valence electrons 7 and 7. Isn't that fun? That's kind of why I like the old convention versus the new convention. That's one of the reasons. Just to kind of tell you what I mean, the new convention for the group that oxygen is in, 6A, the new convention would be group 16, which is awesome, but not as awesome as 6A. Okay. For 7A, the group number is, the group designation is 17. 7A and 17 mean the same thing. Yeah, it's so cool. So let's look at we said that that last column, that last group actually has three names. They're called the noble gases, they're called the rare gases, and they're called the inert gases. And I'll try to kind of this week kind of say why this is, but actually the fact that they already have 8 valence electrons, that's why they basically put their thumb up and they're like, I'm done. I'm happy. I got electrons I want. I don't want any more. I don't want to give any more. Okay, so that's actually kind of how that works. All right. Cool. Gotta love that Bohr and Schrodinger. So now we have just kind of an assortment of questions. And I'll give you a minute. You can kind of use your notes, but this is kind of intended for you to kind of think through a little bit. So these might be questions of the type you might see on your test with regard to the periodic table. So kind of take a minute. Actually, kind of see, are there 4 slides with questions? Oh, 3 slides, yeah. Got 3 slides with questions. Kind of give you a few minutes and we'll look at them together. I see some flipping back and forth. That's good. Flipping back and forth is good. My favorite questions are the ones where you just get to say you get a choice of what element to put. What is your favorite element?
I have a question.
Mm-hmm.
Okay, why, on our periodic table does it have hydrogen twice, here and here?
It's something like we've been talking about. Sometimes hydrogen behaves like these elements,
Okay.
and sometimes hydrogen behaves like these elements.
Okay. I've
So,
never
yeah.
seen that before, so I was just
Yeah,
curious.
that's a good question. So we're kind of an assortment of done and not done, but let's go ahead and take a look at these. So I'll kind of ask metal or non-metal. So how many people think sodium is a metal? Me too. It is definitely a metal. Very good. How many people think carbon is a metal? Nope, carbon is a non-metal. You got it. Carbon is a non-metal. So I think you can hold up fingers. Okay, get your fingers ready. The group number for the element chlorine. What's the group number? Let's go with the old-timey, the A, all right? What's the group number? Yep, very good. Okay. What is the period for potassium? Use your fingers. We can do that. 4, very good. So it was 7 for chlorine's group number, 4 for potassium's period. Perfect. On the count of 3, shout out your favorite noble gas. 1, 2, 3. Okay, very good. Anything that's over there at 8. I'm going to do the next ones like that too. So 8A are the noble gases. Perfect. On the count of 3. Now, the louder you shout, the more your element gets acknowledged. Okay? The count of 3. Give an example of your favorite halogen. 1, 2, 3.
Bromine.
Okay, that may be better. So 7A. 7A are the halogens. Now this one's specific, right? Because it's almost like a grid. It narrows it down to group 2A and period 5. Who wants to tell me what that is?
SR.
It is SR. Strontium. Very good. SR. You got it.
What's that called?
Strontium. Like strong, but strontium. Okay, the next one narrows it down to group 6A, period 3. 6A. Sulfur. Sulfur. Very good. And the last page. All right, we talked about this. Valence electrons for borons. Get your fingers ready. Valence electrons for boron. 3 valence electrons for boron. I'm liking it. 3 valence electrons because it's 3A. Valence electrons for barium. So you find barium. Okay. Fingers, please. 2 valence electrons for barium. I'm liking it. Valence electrons for carbon. Fingers. 4. Awesome. Carbon is 4 valence electrons. And then get 2 hands ready. How many valence electrons does that rare gas xenon have? Which is my favorite rare gas. 8. Very good. 8 valence electrons. Perfect. Okay. So we're going to do those slides coming up, but I wanted to get the assignment slide. So these will be due when we meet again on Friday. Okay. And I don't have them pulled up for you, but I think you should do fine. Now, one last thing before you go. I want to show you something that can be potentially addictive. If you Google, are you familiar with the tile game called Mahjong? Okay. If you Google Mahjong and chemistry, you'll come up with this link. And I'll also put this out under Twitter. Okay, but here it is. So you'll come up with a link. Not that one. Why did you do that? Don't touch you. Bless you. There. It'll look like this, actually. Okay, I got this from Googling Mahjong and chemistry, and it's called Stetson. So actually notice that I've got it on my iPad, so the same game I'm going to show you, this is on the PC, the game I'm going to show you, but it's also on the iPad and the Windows and such. So what you're going to want to do is right up here at the top where it says which game to choose, you can either choose, notice there's different games, chemistry games. You might want to choose valence electrons, but down here is what I thought I had in mind. Notice it says elemental symbols intro. So that's probably what you want to do. Click new game, okay, and then you get to kind of test how well you know your names with the symbol. So for instance, but you can only click on them if they're available. So let's see, I see SN, that's a tough one, actually that's tin. So SN is the symbol and tin is the name, so they go away. Okay, this is totally addictive. Let's see, sodium. Sodium is Na, but I don't see an Na.
It's on the far right.
But is it like
It's on the far
available?
right.
Oh yeah, it is, thank you. Sodium, very good. Those two can go away. I love Mahjong. This is chemistry Mahjong. So, okay, that's all I have. So see you in lab tomorrow.